Demystifying network communication, a look at OSI and TCP IP models. Imagine you're sending a care package to a friend across the country. The package goes through many steps: sorting at the post office, transportation by truck and plane, and finally delivery. Similarly, data travels through layers in a network before reaching its destination. Reference models, a roadmap for communication. Think of reference models like blueprints for network communication. They define how data is formatted, packaged, and transmitted across different devices. Two prominent models are OSI Open Systems Interconnection. This is a conceptual framework with 7 layers, each handling a specific task. It's like a detailed blueprint for network communication. TCP/IP Transmission Control Protocol Internet Protocol. This is the dominant model used in the Internet today. It has a simpler structure with 4 layers, focusing on practicality. Concepts of layers, working together like a team. Each layer in a reference model acts like a specialist in a team. They work together to ensure data reaches its destination. Application layer top. This is where you interact with programs like web browsers or email clients. It initiates communication requests. Example, clicking a link in a web browser. Presentation layer. Imagine a translator. This layer prepares data for transmission by formatting it in a way compatible with the receiving device. Session layer. This layer establishes, manages, and terminates communication sessions between devices. Example, initiating a video call. Transport layer. This layer ensures reliable data delivery. It breaks data into smaller packets, adds sequencing information, and handles errors. Example, sending an email attachment. Network layer. This layer is responsible for addressing and routing data packets across the network. It's like the post office sorting mail by zip code. Example, specifying the recipient's email address. Data link layer. This layer manages data transmission on the physical network media cables or wireless. It adds error detection and correction mechanisms. Example, checking for errors in data transmission over a cable. Physical layer bottom. This layer deals with the physical transmission of data bits over the network cable or wireless signal. It's like the postal worker delivering the package. Protocols and layer interfaces. Speaking the same language, each layer uses protocols, which are like special languages devices understand within that layer. Protocols define how data is formatted, packaged, and exchanged between devices at the same layer. Layer interfaces are the meeting points where layers interact and exchange information. PDU Protocol Data Unit. Imagine a package with different sections. A PDU is a unit of data that travels through the network. Each layer adds its own header information to the PDU as it travels down the OSI or TCP/IP stack. TCP/IP Reference Model, a practical approach. The TCP/IP model combines some layers of the OSI model for simplicity. Application layer, similar to OSI. Transport layer, similar to OSI. Internet layer, combines the network and data link layers of OSI, focusing on addressing and routing packets across the Internet. Network access layer, combines the physical and data link layers of OSI, dealing with physical data transmission. Remember, both models provide a framework for understanding network communication. OSI is more theoretical, while TCP/IP is the practical workhorse of the Internet. By understanding these models, you gain a deeper appreciation for the complex yet efficient world of network communication, ensuring your data journeys smoothly from your device to its destination. Testing your network knowledge. Questions on reference models. Question: what is the role of the presentation layer in the OSI model? Solution: the presentation layer acts like a translator in network communication. It prepares data for transmission by formatting it in a way compatible with the receiving device. This might involve character encoding, encryption, or compression to ensure the data is understood by the recipient's system. Question: why does the TCP/IP model combine some layers of the OSI model? Solution: the TCP/IP model aims for a more practical approach. By combining the network and data link layers of the OSI model into the Internet layer, it simplifies the overall structure. This focus on practicality makes TCP/IP well suited for the real-world demands of Internet communication. Scenario: You're sending a large video file to a friend. Which layer of the OSI model is primarily responsible for breaking the file into smaller packets for efficient transmission? Solution: the transport layer is responsible for ensuring reliable data delivery. In your scenario, this layer would break the large video file into smaller packets, add sequence information to ensure proper order upon arrival, and handle any errors during transmission. Question: what is a PDU, and how does it relate to the reference models? Solution: a PDU protocol data unit is a unit of data that travels through the network. As it journeys down the OSI or TCP IP stack, each layer adds its own header information to the PDU. This header might contain information like source and destination addresses, error checking codes, or layer-specific controlled data. Imagine a PDU as a package with different sections added by each layer for proper handling and delivery. True or false? The OSI model is the dominant model used for Internet communication today. Solution: false. While the OSI model provides a valuable conceptual framework, the TCP/IP model with its simpler structure is the dominant model used for Internet communication today. TCP/IP's practicality and focus on implementation make it the preferred choice for real-world network operations. That's all we have time for today on understanding reference models in network communication. Hopefully, this breakdown of OSI and TCP/IP models helped shed some light on how data travels efficiently across networks. If you enjoyed this video, be sure to give it a thumbs up and hit that subscribe button. Don't forget to share this video